All right, word problems. So this is going to give you some context into why it's important to do what we're doing with implicit differentiation. So I'm just going to walk you through them real quick. And it just, like I said, it's going to give you context instead of just wondering what all these random numbers and stuff mean. So the first problem that we have says that there are two cars at an intersection. So look, there's the intersection. Okay. One is traveling west. Okay, 4 seconds later, it is 19 feet from the intersection. Okay. At the same time, another car leaves the same intersection heading north. So 4 seconds later, it's 27 feet from the intersection. So what is the point of them saying it's 4 seconds? They want you to know that the time spent to get from here and to here is the same. Okay? Because it would throw things off if this was 3 seconds and this was 12 seconds. Okay? So they want you to know it took the same amount of time to get from here to here as it did from here to here. Okay? That's the point of the 4 seconds. Now we're moving on. So it says, if the speeds of the cars at the instant of time are 7 feet per second, so dx is going to be 7. Why is it dx? Because it's a horizontal movement and your x-axis is horizontal. Okay? And dy is going to be 14 feet per second. Okay? Find the rate at which the distance between the two cars is changing. So what's the shortest distance between 2 points? It is a straight line. So you've just drawn a right triangle. So you should fondly remember the Pythagorean Theorem says x squared plus y squared, or a squared plus b squared is c squared. Okay, so x squared plus y squared is the hypotenuse squared, or the distance squared. So I'm just going to put hypotenuse squared. Okay? That's your formula. Now be very, very, very careful, because at this precise moment in time, that's the location of this car. At this precise moment in time, that's the location of this car. So we can't start filling this stuff in yet. Okay? Not yet. So here we go. I'm going to take derivatives first. So I've got the first derivative, or sorry, not the first derivative, but as we go, this derivative is 2x dx plus 2y dy equals 2h dh. And what it's asking is, how is the distance changing? Well, this is the distance, and we want to know how it's changing. So we're looking for the change in distance, or we're looking for the change in the hypotenuse. So at this point, I've got 1, 2, 3, 4, 5, 6 variables. Well, the good news is I know 1, 2, 3, 4 of them, and using Pythagorean Theorem, I can figure out this one. Okay, so I'm going to use Pythagorean Theorem. So 19 squared plus 27 squared will equal this thing squared. So what is 19 squared? Hang on. So I have 19 squared, flip, 19 squared plus 27 squared is 1090. So that's 1090, which means the square root of that is this side. Okay, I don't care what the hypotenuse squared is. I care what the hypotenuse is. So now I know what x is, I know what y is, and I know the hypotenuse. I know how x is changing, I know how y is changing, and now I can figure out how the hypotenuse, or the distance, is changing. Okay, so I've got a 2 times an x, which is 19, times dx, which is how x is changing, is 7, plus 2 times y, times how the other car is changing, which is 14, equals 2 times h, which is the square root of 1090 dh. And now I'm in algebra world, where all I've got to do is figure this side out and divide it by 2 times that square root. So what I have so far is, hang on, I have 2 times 19 times 7 plus 28 times 27 is, that gives me 1022 on this side. So I've got 1022 equals 2 times the square root of 1090 dH. So be careful on your calculator. When you divide 1022 by this, you better put this in parentheses. Otherwise, it's going to divide your answer by 2 and then multiply. Okay? So, I'm going to check that one more time. So 14 times 19 is 266 plus, that gives me 28 times 27, gives me 1022. Awesome. All right, divided by, and then I have 1022 over 2 square root of 1090 will give me dH. So remember, put this part in parentheses. So divided by, parenthesis, I'm not used to using my phone for a calculator. All right, 1090 is, and that gives me 15.47 equals dH, and it says to round it to 1 decimal point, so that means 15.5. What did you just figure out? You just figure out that as this car is going this way and this car is going this way, at this precise moment in time, their distance is changing from each other at 15.5 feet per second. Okay, so real life example of why we do implicit differentiation. So let's do it again. We have, all right, effect of price on demand for tires. So suppose the quantity demanded weekly of the Super Titan radial tires is related to its unit price by the equation. So I've got P plus X squared is 196. Okay, P is measured in dollars. X is measured in units of 1,000. How fast is the quantity demanded weekly changing when X is 8, P is 132, and the price per tire is increasing at the rate of $2 per week? What on God's green earth did we just read? Okay, so we are given the quantity demanded weekly is related to the unit price by this. Okay, they've given us everything that we need. P is measured in dollars. Okay, X is going to be measured in units of 1,000. So if I put a 2 in here, that means 2,000. Okay, if I put a 3 in here, that means 3,000. So this means thousands of tires. Okay. How fast is the quantity demanded weekly changing when X is 8, P is 132, and the price per tire is increasing? So dx, because that's your tire, dp, because that's your tire, is increasing at the rate of $2 per week. Okay, so here's what we've got. So we are given price plus the quantity of tires in thousands squared equals 196. So basically what this 196 means is each tire is $196. Okay, at this precise, or this is our thing. We want to know at a precise moment in time. So what I'm going to look at is I need to take a derivative, because at the exact moment that that we have, hang on, I got to minimize this. That I got to know what I'm showing you. At the exact moment that X is 8, okay, at the exact moment that P is 132, okay, and the price per tire is increasing. So this is price per tire. So it is increasing at a rate of $2 per week. Okay, so we're given 3 variables. We can't evaluate with those until we know what the derivative is. So what's the derivative of 1p? It is dp. Okay, plus what's the derivative of x squared? It is 2x dx. And what is the derivative of 196? It is 0. So now what do we know? Well, there's no p to evaluate. Okay, so that's not going to have any effect on our problem whatsoever. But I do know that dp is 2 because it's increasing at the rate of $2 per week. Okay, so dp is $2 plus 2 times, what do I know that x is? Okay, x is going to be 8. And then what do I know that dx is? Well, that's what I'm trying to find. Okay, that's what I'm trying to find. So I'm looking at dx, and that goes to to 0. So now I have 2 plus 16 dx is 0. So subtract 2, divide by 16. So I get dx equals -2/16. Okay, so when you do -2/16 in your calculator, so -2 times, or divided by 16 gives you a -0.125. But you've got to remember you're reporting that in thousands. So you need to multiply this by 1,000. So times 1,000 will give you -125. So dx in this case is going to be a -125. What does that mean? It means that your quantity demanded weekly is dropping by 125 tires per week. It is dropping by 125 tires per week. All right. So let's do another one. We have P. So it's in effect the same thing. Equals 1/2 x squared, or sorry, minus 1/2 x squared equals 48. And this is the effect of price on the supply of tires. The last one was the demand of tires. So suppose the quantity X of Super Titan radial tires made available each week in the marketplace is related to the unit selling price. So here's the unit selling price. Here's the quantity made available. X is measured in units of 1,000. P is in dollars. Okay, so this is the equation that we're given. How fast is the weekly supply of Super Titan radial tires being introduced into the marketplace at the exact moment when X is 7, P is 72.5, okay, and the price per tire is decreasing at the rate. So the price per tire is decreasing at the rate. So -2. Or sorry, -6. -$6 per week. So how is the price changing? It's dropping by $6 a week. Okay, so first thing we got to do is take a derivative. So the derivative of P is 1 dP minus, drop your 2 out front so your fraction reduces and you're left with X dx, and then that's going to be equal to 0. So I want to know, how is the supply going to be affected by this whole thing, which means I'm trying to find dx. Do I know what dp is? Yes, I do. He's -6. Minus, do I know what x is? Yes, I do. He's 7. Do I know what dx is? No, I do not. That is what I'm trying to find. Okay, so I'm going to add 6 to both sides. And then I'm going to divide both sides by -7. So D is a -6/7. Now, this is going to be in tires per week. Okay, so you just gave me a fraction. So if I do -6 divided by 7, I get -8571. So -8571. We'll multiply that by 1,000 because we're measuring in units of 1,000. So what I get is, rounded to the nearest tire, is it's dropping by 857 tires per week. Okay, it is dropping by 857 per week. All right, so the last one. Actually, I'm thinking you can do the last two. Okay, so it's essentially the same thing. You've just got to label what you're doing. Okay, very carefully. And then after you take the derivative, then you start substituting in. So for the last two, you're literally just going to be given everything but one variable. Okay, so you just got to shove it on in there. Now, So that means you're ready for your chapter 3 test.